In this video, I will explain how to find the nth term in a quadratic sequence. So I have two examples for us to work through here. Let's look at the first example. We have the sequence 5, 15, 29, 47, 69. So the first step to finding the nth term of this quadratic sequence is we first need to find the first difference between each consecutive value. So we'll say to go from 5 to 15, what do we need to do? We need to add 10. And now to go from 15 to 29, what do we need to do? We need to add 14. From 29 to 47, we would have to add 18. And to go from 47 to 69, we would have to add 22. So that's the first difference. Now what we do is we find the second difference. So to go from 10 to 14, what do? We would have to add 4. Now to go from 14 to 18, what do we have to do? We would have to add 4. And to go from 18 to 22, we would have to add 4. Now if you do this correctly, all of these numbers in this second difference row should be the same, and they are. So this is a telltale sign that this sequence is a quadratic sequence. So the way that we find the first term in our quadratic equation that we'll write is we take this difference, this common difference right here of 4, and we divide it by 2. So 4 divided by 2 is 2. So the first term in our equation will be 2n squared. Now, the way that we find the linear term and the constant is we're just going to rewrite the original sequence. So let's go ahead and write 5, 15, 29, 47, 69. And what we can do is we can plug in values for n that correspond with whatever number this is in the sequence. So for example, this is the first term in the sequence, 5. So if we plug in a 1 for n, we get 1 squared times 2, that's 2. Now this next term, 15, this is the second term in the sequence. So in this case, n would be equal to 2. So if we plug in n is equal to 2, we get 2 squared, that's 4, times 2 is 8. Now for the third term in the sequence, we'll plug in n equals 3 into this equation. So 3 squared is 9 times 2 is 18. The fourth term, we'll plug in 4 for n. So 4 squared is 16 times 2 is 32. And lastly, the fifth term, we've got 5 squared, that's 25, times 2 is 50. So what we can do is we can subtract each of these values from the corresponding value in the sequence. So 5 minus 2, that's 3. So I'll say we'll subtract these. 5 minus 2 is 3. 15 minus 8, that's 7. 29 minus 18 is 11. 47 minus 32 is 15. And 69 minus 50 is 19. Now, the linear term in our equation is going to be whatever the common difference is between these numbers. So to go from 3 to 7, you'd have to add 4. From 7 to 11, you'd have to add 4 again. From 11 to 15, add 4 again. And from 15 to 19, you'd add 4 again. So in our final equation, we would have 2n squared plus 4n. And to find the very last term, the constant at the end of this equation, all we say is, how do we go from this common difference of 4 to the first value right here, this first difference? To go from 4 to 3, we would subtract 1. So we'd say minus 1. And that's going to be our final answer. So this equation we can use to find any value in this original quadratic sequence. For example, if we plugged in a 5 for n, if we wanted to find the fifth term in the sequence, we would get 5 squared, that's 25, times 2 is 50, plus 4 times 5, that's 20. So 50 plus 20 is 70, minus 1 is 69, and that is indeed what the fifth term is in this quadratic sequence. So let's check out another example. We have the sequence 4, 5, 8, 13, 20. So we'll use the exact same process to find the quadratic equation that we can write to summarize this sequence. So to go from 4 to 5, we would add 1. So remember, we're just finding the first differences. From 5 to 8, we would add 3. From 8 to 13, we would add 5. And from 13 to 20, we would add 7. So those are the first differences. Now let's find the second difference is. So that's from 1 to 3. What would we need to do? We need to add 2. To go from 3 to 5, add 2. From 5 to 7, add 2. And once again, we can see that all of these numbers in the second difference are the same numbers. So this tells us that it is indeed a quadratic equation. So remember, to find the first term in the equation that we'll write, we take this common difference of 2 and we divide it by 2. So 2 divided by 2 is just 1. So our first term in our final equation that we'll write is going to be 1n squared, or just n squared. Now, to find the linear term, we will do the same process as the first example. We'll rewrite the original sequence, and we'll plug in values for n that correspond to the number in the sequence. So for n is equal to 1, we would get 1 squared times 1, that's just 1. Remember, we're going to subtract all these values eventually. All right, for the second term, n is equal to 2. 2 squared, that's just 4. For the third term, 3 squared, that's 9. For the fourth term, 4 squared, that's 16. And for the fifth term, 5 squared, that's 25. So remember, we just subtract all of these numbers from the original terms. So 4 minus 1, that's 3. 5 minus 4 is 1. 8 minus 9 is negative 1. 13 minus 16 is negative 3. And 20 minus 25 is negative 5. So remember, the last step is we're just finding the differences between these numbers. So to go from 3 to 1, what do we need to do? We need to subtract 2. To go from 1 to negative 1, subtract 2 again. To go from negative 1 to negative 3, subtract 2. And to go from negative 3 to negative 5, subtract 2. So this number right here, this negative 2, will be the coefficient for the linear term in our equation. So we're going to write 1n squared, or I'll just write n squared. We don't need the 1. N squared minus 2n. And remember, to find this constant at the very end, we just have to say, how can we go from negative 2, this common difference, to the first number right here? So to go from negative 2 to 3, we would have to add 5. So we'll say plus 5. And that is our final answer. So again, we can use this equation right here to find the nth term in the original sequence. So for example, if we plug in a 5, we would get 5 squared, that's 25, minus 2 times 5 is 10, so 25 minus 10, that's 15, plus 5 is 20. And that indeed matches what the fifth term is in the original sequence. All right, thanks for watching, guys.